Good afternoon. Can you all hear me? Both. Oh, there we go. Good afternoon, everyone. Let's try that again. Good afternoon, everyone. All right, we've got people that aren't here listening, so we need to let them know we have some folks in the room. My name is Howie Ferguson. I'm with the University of Florida. I'm the chair of the conference committee for COA, and along with the folks who already welcomed you, for folks who walked in since then, welcome. If you just walked in, you missed a great little session on the Lake Nona development here in Orlando. What we're now about to get into, and most of us that know a little bit about what we're about to get into are pretty excited. Kind of feel like COA's a little late getting on board with this, but we're thrilled to have Kimon Enuma here with us to sort of launch a BIM storm, and it was obviously not planned that it would be on the heels of another real storm that's actually affected some of our speakers and attendees. But we're glad all of you are here, and we're really excited about this initiative. Just real quick on Kimon, he is and of course I had the page open and now I closed it, but Kimon is a USC Trojan, been practicing architecture for about 3 decades, and doing BIM before I think it was even called BIM since 1993. So he was doing it before it became cool. He's on the board of directors for the Building Smart Alliance, and next year will be AIA's chair for the technical architecture practice, which he might be able to explain to you. I'm not even sure what that means, but I know it's a liaison thing along the lines of what we're about to get into. So with that, Kimon, it's yours.
Thanks for having me here. Really excited to be here in the middle of the storm. I almost decided to change the name just given that this hurricane's going on, but we just decided to go ahead. We have people online. In fact, people that weren't able to join us here today are also online joining us virtually, and we're going to have, the session's going to be interactive. We're going to try and show, we're going to go through a lot of material, so I hope we don't get everybody's head spinning, but we also want to show how simple it is in many ways to get started, and that's been one of the themes this morning at the session of the handover session from BIM to facility management operations was you just need to get started somewhere. I'm an architect, been using BIM for a long time. We're also a software development company. We kind of stumbled into that. It was an intentional. We started working with BIM in the early 90s and worked with databases and systems, and now we kind of do both. We're consultants, we're architects, but we're also software developers. We partner with a lot of people actually that are even in the room here. A lot of the other vendors and other consultants that we've worked with in the past are here and online as well too. So our system is called the Enuma system. You'll see a little bit more about it later, but we're going to focus on BIM Storm. And I'll explain as we go along what that really is about. We've assembled what we call the Dream Team. We're having a little fun here. When I first got invited to come here, I was asked by Mike Koenig, can you come and present what's going on in the world of BIM and BIM Storm? And somehow it evolved to, well, let's do something live, and all of a sudden we have a lot of other people piling in too, so it's okay. We're having a little fun. We want to keep it, rather than just a series of PowerPoints, we're going to try and keep this interactive. So we have a large group online. There's some that I might have missed the name. I'm still getting emails actually right here as people are jumping in, so I might have missed a few people that are jumping in, but we're going to show what's going on today, and then we're going to continue through tomorrow and do a wrap-up session on Friday, because we want to show kind of the progression of things as things start swirling around in this kind of a storm. The name BIM Storm obviously comes from BIM, Building Information Modeling, and Storm is kind of like a play on brainstorm. And we've been doing this for years. As far as our own firm, we've been working like this since the 90s, but we decided to open this up about 4 years ago, and this is actually Penn State, John Messner's team involved in one of the first BIM storms for Los Angeles, where we had 130 teams from around the world on a 24-hour workshop designing over 420 buildings at varying levels of detail using a lot of different tools. There's no single tool that can do everything, and that's one theme here. You really can't do it with one application. It's really a lot of different things have to fit together. And you notice that this generation, they're wired for this already. They expect nothing less than to be able to collaborate like this. So it's really about communicating. The tools, in many ways, have to go away so we can start making decisions as we go through projects. And as owners, there's a lot of very valuable decisions, as we all know, are made in the early part of design, through design and construction, then off into operations and maintenance and handover. And we're all challenged with information silos, and different versions of software, different flavors of outputs and inputs. You have to export data from one and import it to another, and you lose data, and that's a constant challenge that we have to overcome, because we're not going to be able to solve the wicked problems we're trying to address in this world today without being able to connect the dots. And as we know, the building industry has a huge impact on a lot of different things, and I think we can actually make the change collectively. So the technology has existed for years to be able to get online, make a reservation, see a floor plan of a plane, and see your seat appear and disappear as you buy it, and see the price change as you're getting ready to buy it. Simple buttons, you can even do it on iPhone or Android now. A lot of complexities happening in the background, but to the user, it's a yes, no. Do you want to buy this ticket or not? And then it says, okay, you're going to New York, you probably have these other things that are available, other hotels are available. Oh, the flights are canceled today because of a hurricane. So that type of information allows us to make decisions in a simple format. It doesn't allow you to reserve the pilot seat, for example. So it has these rules in it that you might not even be aware of, and there are very few mid-air collisions in the airline industry. There's obviously challenges they have with overbooking and things like that, but that's almost built into the system. Unfortunately, in the building industry, we still have a lot of mid-air collisions. We have a lot of things just crashing against each other. So it's a lot of bad things happening, but it's also a huge opportunity to make change. And that's what BIMstorm is really all about. It's about expanding the horizon of what we can do. And from the very beginning, from even 20 years ago when we first got into this, we realized it's not about the software or the technology. It's kind of a cultural shift that needs to happen to get everybody on board. And that's why we opened up BIMstorm and said, let's see how we can collaborate. So as we know, with these simple tools that start off when Facebook first came out, people thought, oh, what a cute tool. You can start communicating with your friends. Well, all of a sudden, there's revolutions happening driven by that communication capability that didn't even exist a few years ago. So that tectonic shift of being able to connect the dots and collaborate is what BIMstorm's about. How do we push the envelope and make it simple and not have to be all rocket scientists to be able to use the tools? You don't have to be trained on how to use these simple tools like an iPhone or Android and on the internet with Facebook. It's a very simple process. And it's getting simpler, I think, in many ways because all these apps that are out there. So even from a few years ago, things have completely shifted around, as you know. With smartphones and tablets, we would have never imagined where we haven't even started, I don't think. We're just scratching the surface of where we can go with all of this technology. So it is a revolution. And if we're part of the revolution, it's great. If you're outside looking in, it's not that great. So it's really a call to say, let's all jump in. The building industry, we're ready for this. We're going through a lot of training of the younger generation on how to use these tools. This is a grant that's going on in San Diego for Southwest College, where we're training vets and students on how to actually jump into BIM, even though they might not know very much about BIM, and energy management, connecting the dots together. We're going to be going through a lot of different presenters here. Calvin, are you here? You're up wherever you are. Oh, there you go. Okay, come on up. And I'll introduce Calvin. Calvin and I are, Calvin's an ex-AITAP, Technology and Architectural Practice Chair of AITAP, and I'm a 2013 chair coming in. And Calvin is going to talk a little bit about BIM score and what that's all about in relation to this and also to the rest of the industry.
Thank you, Kimon. Good afternoon all, and also good afternoon or good morning to those who are joining us remotely.
Oops. Oh, what happened here? It's going into presentation mode. Do I have to shift it? I'm not good at PowerPoint. Let's see. How do you do that?
Can we just go back to presentation mode? Or?
Yeah, it went into. Oh, I see. Okay, that's fine. Yeah, okay, that's good. It's working. Yeah. Okay.
Yeah. Okay. Can I use this?
Yeah, go ahead.
Okay. Cool. So, what I'd like to talk about is that how are we going to report or observe the storm? As just like what we did in the last couple of days. So imagine what if we hear all the news in the on CNN and the like, and if there's no mentioning about numbers, if there's no mentioning about the magnitude of the storm, if we just use words to describe, oh, that's a big storm coming up, without describing the miles per hour, the category, or if we do not have a way to report how it may impact the course and the people and the timing of the storm. So what we're saying is that just like observing the actual storm, it is important for us to carry an executive view to look into how is the storm going to impact the bottom line, the infrastructure, how many people are going to be affected, and what may be the actual impacts in terms of economy and actual path and actual consequences. So to take that analogy further, what we would like to do at this BIM storm with the BIM score team is that we will be observing how well are we planning in preparation for this storm. How is this storm going to bring ultimate value to the owners community? How are we going to understand the impact of BIM to the people, to the course of the facility life cycle? How are we going to understand that the interrelationship between the technology infrastructure? And also, more importantly, we can see all these digital tools happening in the next 2 days, but how are those going to affect the bottom line of the owners and the mission and the business that we do? So to take that analogy further, what we'd like to do throughout this BIM storm process is to provide an objective, quantifiable way for us to evaluate, like the speed, like the gust, like the economic impact of the storm. In this case, what we do is that our team actually has interviewed the California Community College, a subject of this storm, the hypothetical owner of this project, and understand what are the traditional deterrence way without BIM in their facility design and construction process. What we find is that there's not explicit use of BIM or VDC, that there are some model use in terms of visualization and energy. At the same time, the team is getting on board, but there are not much metrics and measure of success for VDC. So what we'd like to do is to take the existing practice as a benchmark, and throughout the next 2 days and beyond, see how the gauge, how the speed meter, it's going to change as we see different activities happening. For example, when we talk about doing the score, doing the gauge, rather than on the category level, what you hear is that we focus on 5 innovative practices. By conventional practice, it does not mean that it's a bad project with a bad schedule or cost conformance. It's just meaning that the project is not leveraging the use of BIM to any potential. By innovative, what you see is that innovative practice means that the team is able to use some innovative solution that are very much one of a kind. So to explain our scoring spectrum a little bit further, in that by planning, what we want to understand is that why are we doing BIM? What is the measure of success? What are some of the guidelines? How are we getting the team ready to succeed? So we will be monitoring this throughout the next hour and a half and the next 2 days to see how the team is able to have clear idea of why we are doing BIM. One example is that our BIM score team has come up with 7 major categories of why we are doing BIM. And so we'll be using that as a checklist to monitor how the team is doing in this BIM storm. In the second part, we focus on people and process. Just like the actual storm, how does it impact our daily lives and our processes? So we want to make sure that our team able to collaborate in a seamless manner. Are they able to leverage real-time technology to reduce the time that they need to wait for information? Are they able to come up with alternatives that not only think about the sales and the marketing, but the full facility life cycle from design all the way to facility operation? Third, it's where technology comes in. Even though we are all passionate about the technology, we want to make sure that we are using the appropriate technology for the right purposes. So why are we using that? Are we just using that for pretty picture, for pretty animation? Or are we able to come up with good, genuine alternatives that can help us to make good, informed decisions? So what is the level of maturity? Are we able to leverage on automation, on cloud computing, on better integration, rather than just a desktop-based application? Finally, we want to measure how successful is that. How long does it take from an alternative being generated until we can evaluate them? How long does it take when the designers come up with an approach until the engineers can do some analysis? So we will be tracking the actual performance of the storm by means of many performance indicators, from communication to project delivery to schedule. So in this 5-minute introduction, I just want to lay out the framework and ask you all to join the storm. And at the same time, you can watch the score on our BIM Score website and come up with how we all can navigate through the opportunities and the benefits of BIM. And thank you, Kimon, for inviting us. We are glad to be part of the team.
Thank you, Calvin. And one thing with BIM Score, there's actually a team all the way around the world pretty much participating in this, including Tony Ranella, who's not going to be here, but he's going to log in remotely on Friday from San Francisco to give us an update. So thank you, the BIM Score team, for being part of this. All right, so let's move on here. So a little bit about the California Community Colleges. This is one of our clients. So the great thing about the California Community Colleges is we're able to share what they do with their projects and buildings. We work with other clients like GSA and Homeland Security that we can't share the data. But in this case, we're actually able to open it up, and that becomes a great sandbox because we're working with real data and real projects. BIMstorm, obviously, we're compressing it just to a few days, so it's not the real project would not be done in a few days, even though we've seen some things happen in China that kind of blows us away as far as building things really fast and things. But we want to compress that to create a scenario where we can actually test real-world scenarios with real data and also expand it out and say what would happen if we were able to do something else with it. So they have 5,200 buildings. We walked into their project, and they're a big state, obviously. California is a huge state, 5,200 buildings. They have over 2.4 million students statewide. It's larger or close to the population of Chicago. They have 24,000 acres, larger than New York City combined. They have 72 million square feet of facilities, 32 Empire State Buildings equivalent of that. 120,000 rooms. If you stretch them edge to edge, they would actually be 680 miles long. And we actually did this because we have the BIMs of all the buildings, so we can actually line them all up and say how long is that line of rooms. So you can just imagine the complexity and the operational costs that they get into, and obviously as an owner, and they're a group of districts that are autonomous in a way. It's like a federation, as they describe it. They have construction billions of dollars. They obviously have resource constraints. They use a lot of energy, and they have a system, or they've had a system for many years now that was not BIM. It's called, and it's still in place. It's called the Fusion system, which is essentially their facility database. Before they were using Fusion, each district, 112 campuses, were using Excel and Access and paper documents and some kind of a facility management system, different flavors of things, and they couldn't roll it up to the state level and say who's spending what's the condition of the buildings, where are we spending these billions of dollars, how do we allocate money. So if you can't see your facilities, your portfolio, how can you even start making decisions? This is a large owner, obviously, but I think this happens at every scale, and we've worked with many different levels of owners. And it's the problem is pretty typical. So they decided to implement this Fusion system. This is their software. They decided instead of going out and buying an off-the-shelf software to create, it's basically a database. It's not that complex in the background. It's a database that it's a pretty common database, but it does amazing things because then you can hit the database on the web and say, roll up and show me square footage or condition of spaces. And this is not a simple thing to do because most owners, even at the level of even identifying if a building exists sometimes, for example, is a challenge for a lot of owners in many cases, especially does this room exist or what's the condition of this room or what systems are in the room. And now we're starting to touch into BIM, obviously. So what we did with them, and they had a lot of tabular reports. You can pull up tabular reports of square footage and cost and et cetera, et cetera. This has been going on for close to 9 years now. They can manage their facilities. They could look at projected costs for construction and budgets. They had a lot of CAD files that were attached to a database, so you can search the plan, but a CAD file is a static document. If you imagine that airline reservation system, imagine if you went to the airline reservation system and decided to create a CAD or a PDF of every airline's seating arrangement, including which one was occupied right now, and decided to create a book out of it. And we actually calculated this. If you did that from Orlando today and said, I want to capture all flight options from Orlando today, it would fill up this part of the room with binders to the ceiling, and it would be obsolete the minute you print it because there's so many different options and so many different seats. So the message there really is that static CAD files do not really do what we need to do in this 21st century as far as managing information of our portfolio, yet they do it with airlines. So BIM comes into the picture, and they're using BIM as well. Some projects are being done in BIM. Obviously, there's not 5,200 BIMs of design and construction models because a lot of the buildings are existing. They also use geographic information systems, location-based database as well of that, a server that says here's a dot on the map of the campus. Click on the dot, you can pull up more information. That dot is actually a campus, right? As you keep drilling down, you get more and more information. They have demographics, so they can say where are we going to have population shifts. So the message here is that there's really a ton of data just in this owner alone. And as we go through this BIMstorm process, one thing just to keep in mind as we're showing you all this, you don't have to touch all the data. In fact, we don't want everybody to touch all the data. It would just be overwhelming. But we want everybody to be talking the same language. So when I say I want to get on a flight from MCO to LAX, I end up in Los Angeles because there's a code called LAX, or there's a standard that says this is LAX. So that's what happened with them. So another misconception is that it's not, the solution is not to create one database or put it in one piece of software. That's not how the internet works. The internet is a lot of databases. The technology problem is already solved. It's a lot of databases talking to each other. Therefore, you can go on Expedia and hit the Delta database and the American Airlines database. They could give you a bid in real time. You can decide which one to buy, but they're not releasing their strategy of how they price tickets, but you can kind of get a sense of what's going on in the background. It's that kind of an ecosystem that creates something that looks more like this. A series of databases about facility, about geography, about building automation systems, about standards, and many other things, facility data, operational costs, et cetera, et cetera. This, I'm sorry, this is a little bit hard to read, but along the bottom, if you think of a lot of these software applications that we've been using for years, and which we still use, the CAD and the BIM and the engineering applications, the business applications, and the blue lines between them are how do we export data from one and import it to the other? How do we export Excel files and import it to the next one? Still very important, and we still have to do that for many years. It's going to be a hybrid environment. But imagine these tools, if they were publishing out to a database that was a common database that says, here's all our information about our spaces. Then along the top, imagine the iPad and the smartphone revolution that we've seen happen in front of our eyes, to be able to hit on something and say, show me the Starbucks, and show me where my friend is, and show me where the storm is, and show me where my flight is, and show me how much it costs, all that stuff, and I want to buy it. That's already there. The technology is there. How do we bring that into the building industry? It's already there for us to use, right? But as an architect, I've said this for many years, I've been very frustrated with how slow we've moved there. So now's our chance to actually, it's a tipping point, I think, and we're seeing it start to happen. And these apps along the top can be very simple apps that you don't have to be trained how to use. We don't want you to be a rocket scientist to use 100 different apps. It's just not going to work. And even the apps along the bottom are very powerful applications, but not everybody could be an expert in BIM or GIS, for example. So that's kind of the concept of the BIMstorm as well. So this is called web services, and this is what the California Community Colleges uses. This is what the airlines use. It's cloud computing. It's on the internet, and you go to the authoritative source to get the information that you need to do something with. So the authoritative source of how much does my ticket from here to Los Angeles cost is from Delta Airlines, but I can buy it from many different interfaces, from an iPhone, from a desktop, whatever. And then you can start plugging these together and creating new solutions on top of that. This is called a mashup on the internet. Cloud computing, you're able to kind of pick what you need and say, I want a cost module, and I want a mapping module, and I want this module, and I want it to work on an Android or an iPhone or on a tablet. The choices are wide open. It's not the software, it's the fact that you can get to the information, and it's not even the data or the information, it's the fact that you can start interacting with somebody and saying, well, what do we think about this cost that's coming into this building? Can we make a change to that? What other options are there? So this web services concept is what we did with the Foundation for California Community Colleges. They had one campus. They said, let's do a pilot project. We did a pilot project with 30 buildings in about a month. Again, a lot of these tools today on the internet move very rapidly. They're kind of iterative, agile tools. They don't take a year to develop. There's still these very powerful, great pieces of software that take longer to develop, but now there's little applications that you can just start pushing out there. So within a month's time, we were able to connect their Fusion data to one of the tools is our system called the Onuma system, and they also had their GIS data, and we connected it to our system. We did not import we didn't go to the California Community College and say, you have great data, give us your data, we're going to import it into our software, and you can throw away your software because we have good software. That doesn't work anymore. That business strategy doesn't work. You have to have a modular approach to say, if you have a good database, you're the authoritative source about naming of spaces or the cost of that airline ticket, and I want to pull it up on a web interface and look at a floor plan of a building. They did not have any BIM, but they had in their facility database, it said something like laboratory, 300 square foot, building 301, GIS coordinates this and this. That minimal piece of information allows us to land that building and that space on the right floor, which means then we can start doing what-if scenarios. What's it going to cost to do this? Imagine a blocking model, which you kind of see in the middle. You don't necessarily have to have a high level of detail BIM to start making decisions about how to manage energy. And with 5,200 buildings, California cannot wait for 5,200 high level of detail BIMs to start managing energy or cost. It's just the whole state's going to burn up by then. So we need to capture that. So they liked the first version of that, and you'll see the results of this. And they said, okay, let's do the entire state. No, they didn't say let's do the entire state. So let's do 3 more districts. We said if we're going to do 3 more districts, let's just open up the whole state, because it's just data. You just open the gates and boom, within an afternoon, literally, or actually it was just a few minutes because we had the system in place, it started populating just like the airline seating schedule. So now we have 5,200 buildings at different levels of detail that you can start seeing in an interface. And that ecosystem, again, is called Fusion, their system. Our system is called the Onuma system, but that's not the point here. The point is that as you start creating modules, you can plug in different modules. So if somebody has another tool that can talk with web services, is how the internet works, they can plug in and say, we have an energy model, or we have a CMMS module. And we subscribed to their data, so their facility data about buildings is coming from Fusion. And then a lot of the amazing thing, within the last year, we're having a lot of other vendors and consultants that are starting to plug into the system. You don't have to rebuild a mapping application if Google and Esri is publishing mapping applications. You don't have to recreate the facility database of the state of California if they already have it published, and you can subscribe to it and say, I can do stuff with that data. I have solutions that can respond to that. It's a very dynamic way of developing things, and it brings the cost way down. But more importantly, you get to a solution a lot quicker. You don't have to wait for everything to be perfect, because the internet is not done, yet we use it every day. So this is kind of a map of this, the 5,200 buildings. Each dot is a campus. Each campus has multiple buildings. This is a mashup of the buildings on one campus that actually had the footprint, the layout, the massing of the building as a shape in GIS. We connected it to that, and this is a BIM connected to the Fusion data. The utility lines are coming from another server. There's about 4 or 5 different servers hitting me here as I open up the web interface. I'm not needing to know anything about the technology. I'm just saying I want to see utility lines and buildings. And I want to plan for the new buildings. The red buildings are new proposed construction, which is coming again from the Fusion server. We actually prototyped this. So instead of the owner saying, we want to build a new gymnasium, we're going to do an Excel file, and then we're going to do a PDF file, and then we're going to print it, and we're going to send it out and give it to the team as far as a requirement document. You're going to design with it and give it back to us. It's all data. Here's our data coming in about our requirements, our existing conditions if it's a renovation. Now we can pass that off as a BIM. So the BIM interface becomes a way to communicate back and forth with these tools. Okay, so one thing, I think I skipped one slide here. Let me see if I wanted to try just to make the point about simplicity, the need for simplicity. Let's actually jump to this for now, and we'll come back to this later. But smartphones. If you pull out your smartphones, this is a 5-minute exercise, a very simple exercise. Smartphones, tablets, laptops, whatever you have, or you can watch what I'm doing here. This is the URL. It's called bimsense.com/171. And we're going to interact with the data live that's coming from the California community colleges. So I'll go through a few steps here one by one so you can see what I'm talking about. So just go to Android, iPhone, or iPad, or whatever device you have, and we'll walk through this together. So it's bimsense.com/171. bimsense.com/171. And you should see, if I have an internet connection here. Oh, I'm still using my connection. That's interesting. It's running off my phone. Does everybody see this on your screen? Whoever's logged in? Okay, this is a work order request. The significance of this is not the fact that it's a work order and that works on an iPhone. This is a very simple application that just says, I want to place a work order. So you place your name and your email address, and there's a pull down here. This pull down is one of, these are some of the 5,200 buildings. We're actually hitting their server now, which is in Stockton. There's a building here called Industrial Tech or Medical Dental Tech. We're going to focus on these two buildings, but let's just go to the Industrial Tech building for now. So I'm in the Industrial Tech building. I'm an instructor in that building. I'm on the first floor or second floor, and I'm in the room called whatever. I'm in my office. And I could say it's hot in here. And I could take a photograph with my iPhone and attach it to it, and I could say how urgent it is. This is actually creating BIM data. It's creating COBie data. As soon as I hit submit, this is a mashup from their data, from our server, from another server. We hit submit. It's going out. It's hitting the admin who has access to the information that says you submitted a work order. So if you guys just go ahead and submit a few work orders. And we'll get back to this later on, and I'll have this URL online as well again. The point of this exercise is BIM does not have to be complex. In fact, in many cases, such as this, you don't want to have to open up a full-blown design and construction model, even though we use that as well, too. You want to be able to have a simple way to get to it, and a simple way to be able to put in a work order. So that's bimsense.com/171, and just go ahead and submit a few work orders, and we'll come back to this later. You could hit the other building too, the clinic if you want, Industrial Tech, just any building you want. It doesn't tell us where air handler unit is in that room, but because in the background is a server that says I am a BIM and you're in room 101 and there's an air handler or a VAV box in that room, all of a sudden the guy that's responding to it has that information that can respond to it. And it could be that he might say, well, I need to open up the full-blown detailed model in Navisworks or other 3D applications, which we'll see later. But for the teacher, you don't want to say, well, in order to send a work order and you need to be trained on how to do this, you need to buy this very expensive software. And there's as many different ways of doing this, in other words. It can't be just one way to do it, because then it becomes very expensive and difficult to get into. All right, so we'll get back to this later. And we showed that. Okay. So that's the work order system. Yes.
We've lost video on the webinar.
Oh, you have? Okay. Technology problems here. I see you guys online. Why don't you take the screen away from me for a second and come back to me.
Okay.
We're going to make this interactive, like I said today. This is not just going to be a straight PowerPoint, so we're going to have our team jumping in. In fact, we see some of the panelists online that are coming on later. Igor Starkov from Ecodomus. We have Jason from Balfour Beatty, and we don't have screen sharing yet. Oh, you know what happened? Somehow, there it goes. I got knocked off the internet earlier for some reason. I'm on now?
Yes. Work order requests administrator.
I'm on, okay. Okay, good. All right, great. Thanks for spotting that. So these work orders, as they come in the back end, there's these models that I talked about from the California Community Colleges. Because we have all the spaces and the spaces are numbered consistently, then we can say, turn that room red, that urgent request just came in. Or open up the more detailed model, which you'll see later on. And another thing, as we were doing this BIM storm, we were preparing the last few days, and this is actually me on the plane yesterday coming in from LA and sending a work order through this system. We were testing, preparing for today how to set it up. So it really opens up how you can actually collaborate and work when you keep the data lightweight like this and you're able to work from anywhere. So the California Community Colleges will have STV VBN coming on later talking about the projects they're doing. There's a lot of different projects coming in. What's amazing, when an owner actually starts setting the standard of I want to name buildings and spaces like this, start simple, because if you can't consistently name and number spaces or consistently name and number equipment, you're not going to get into BIM for operations, facility management and operations. You have to start from both sides. You can have detailed models, but unless you get that foundation in place, it's not going to work. Okay, Rob, are you ready to go live here? This is Rob Bartleman from...
I am here, come on.
Why don't you introduce yourself, and we'll push the screen to you, or do you want me to show something here?
Why don't you just keep rolling through it, and I'll respond to what's on the screen. My name is Rob Bartleman, and I'm a Vice President with STV VBN, and as Kimon has been sharing, we've been collaborating with him with our community college clients, and have been doing a great deal of master planning recently, where we saw the opportunity to help our clients along the lines of what Kimon was suggesting, of helping them make decisions with the great deal of data that they have but don't know how to sort through, or in some cases didn't know they had the opportunity to sort through. So Kimon, I'll let you flip through some of the things on the screen here, and I'll start to respond to them.
Sure. I'll open up the, now we're live here. We're going away from PowerPoints for a while. And some of the stuff that you're seeing here, it literally just came in minutes before I was doing this. I'm kind of going on the fly here just to see what's happening. But we have the Fairfield campus I'm opening up now. This is one of the campus sites for the California Community Colleges in a web browser now. And it's pulling from a lot of different systems, a lot of different tools. We're hitting the Fusion server on the left here. It's going and collecting all the, probably several thousand rooms from the left side here, their names and building numbers. It's pulling in from an ArcGIS server from the Foundation for California Community Colleges. And it could also pull in from the satellite images from Google. So this is what's called a mashup. It's basically I'm bringing in stuff that's relevant to what I'm trying to do here. I'm trying to do a master plan of a campus. And Rob, why don't you explain what this campus is about? This is an actual real project that Rob's team, SDVBN, I'm sorry, I get the name mixed up, has been working on, but we opened it up for the BIM storm, and it's not exactly the final product, right, Rob? We're using the real data, but it's a little bit different, but it's the actual buildings here. So why don't you explain what we're seeing here?
That's right, Kimon. What you're seeing on the screen right now is just what Kimon has been describing, which is the graphic representation of all the data that the state has on the facilities, in this case on the Solano or the Fairfield campus of the Solano Community College District. Ordinarily, this data is a scrolling list of lines of rooms and buildings with square footages and programmatic information. What opportunity has been presented to us here through the use of the software is that we can graphically represent that to our clients, show them the buildings in location on their site, be able to click on any one of those buildings, and through some very quick effort on our part, generate BIM models, rough BIM models of each of these buildings, so that we can start to tie that data to the actual floor plans of the building. Well, you might want to flip to a floor plan of one of those buildings so we can show that. What you see on the screen right now is the colorization of the site plan that is responding to the facility condition index, or that ratio between the cost to modernize versus build new. That in itself is a decision-making tool for the districts to realize that some buildings on this campus cost-effectively are better to tear down and build new versus those that might be green or yellow that might be in a little bit more of a area where you might consider renovation versus building a new building. So in double-clicking on any one of the buildings, you get the opportunity to see some of that data come up right from the Fusion database at the state level. In this case, we've generated these BIM models very quickly. In some cases, we're able to generate these models in half a day or so that we can start to tie this data directly to the buildings themselves. So where in this case, where you're seeing green and orange, you're starting to see still the condition of some of the spaces in there. We've gone through, my team has gone through each one of the buildings on campus and created yet more data for them, and in this case graphically indicating the condition of the different finishes within any one of the buildings. So as our team walked through with iPads, we were able to walk into a room, pull that room down, much like you were doing in that work order, select the room you're in, identify the finish that you're referring to, whether it's the floor or the walls, select that finish, and then give it a condition assessment. And we want to make sure that these condition assessments also line up with some of the standard information that the state is already using, so this data can continue to be a benefit to the district and then to the state as it starts to look at the global amount of information that it may have. Now, this was new to all of our clients because they hadn't seen it in this format. We can also start to say, okay, well, I want to look at the ceilings, but show me the ceilings as their condition may be. And we can start to put some information together about the costs that may be reflective of, gee, we've got a number of those spaces that are in good condition, some of them that are in poor condition, and what are the costs behind some of that. And as you can imagine, as you start to compile this across the entire campus or the entire district, you start to be able to look at, switching topics here a little bit, if we've got carpet in 80% of the buildings, yet we know that the costs of maintaining that carpet long-term, whether it's the installation, the cleaning of it, or the replacement value of it, against the cleaning costs of maybe exposed concrete or stained concrete or linoleum tile, we can start to facilitate our clients' decision-making around the operations and the maintenance of the building too, that over a period of time, they may opt to swap out carpet for hard surfaces or other types of carpet based on the cleaning requirements of that that material or the costs of installing them. What you see on the screen right now, I'm sorry, I'm responding to what I see on the screen happening here really quick. No worries. Is the interface that we used on the iPad itself. Walking through, you see an iPad snapshot of walking through a building, the highlighted room. That's essentially what we were utilizing in this case here. Then the blow up is what's on our screen, walking through that space, clicking on the fact that we had acoustic ceiling tile in that space, and then being able to upload that to the database itself live so that we can start to see that in other forms of viewing the data.
Great. One more thing before you leave, Rob. We're going to go through to demonstrate what we did in the last few days, or you can even do it right now. One thing about this campus, there's literally millions and millions of data points about type of finish and the name of the room and whatever. If you imagine having to manually do that, it is an impossible task. Therefore, you're always kind of throwing data away. But in a database, on the way the internet works, the more the data, the better. As long as it's structured, and as long as you know where the source came from, and as long as you know how to update it as well too. So this data, for example, that we saw at the site level, that the color coding is actually coming from an assessment team that was sent down by the state to assess the condition of the building. Rob's team went in and actually did a field assessment and updated the data, and now they're going to submit it back to the state. So it's this ability to move ownership of data around depending on who's in charge at that point in time. So for the BIM storm, what we did, Rob, you're still online, right?
Yes, I am.
We decided to use this campus, the Solano Fairfield campus, agreed to let us use it to run a planning scenario, and we placed 2 buildings on the site. Actually, before we actually moved it here, just yesterday, we were going through this exercise of where should we place the building. It's not only a graphic that you can view, you can actually grab things and move them. And as I move them around, it hits a bunch of different stuff. So if you start opening up, if we change the room, for example, you would not see it on the work order system you just pulled down earlier. If that room disappeared and I said that room no longer exists because I went to the site and there was a renovation, boom, it's gone from this work order system. Completely eliminates this. Well, what version of the plan are we looking at? So this is a clinic that you'll see later on as well. Other teams are going to focus on this clinic. This clinic is from the Building Smart Alliance, the COBE Challenge, as some of you have heard about COBE, that was done at previous co-events, has a full-blown COBE data on it, all the way down to equipment level, the attributes and manufacturer, all that stuff. We're using this to simulate a series of things that can happen in a project. So we have the completed building with Revit and Navisworks, and Igor is going to be showing this later as well too, from Ecodomus. But we also decomposed it and said, what if an owner said, well, we have this clinic on this one campus. We want to suck up the data from that clinic and create a new program requirement, including all the BIM in it, the COBE data. And we want to change a couple things because certain approaches that we had in the previous design didn't work, and now we want to push it back to the design work. That's creating the loop. It's not a linear process of design to construction to handover and then buy, we're gone. It's design, construction, handover, owners using it now, doing work orders and doing CMS and facility management, and they're realizing that there were some things that they don't want to do anymore in the next building. They can then pull that and use that as a basis for a new design and hand the design team, here's a Revit model, and here's a COBE file of my requirements. So you don't have to read this big stack of documents and interpret the PDF text into a design for us.
And come on, if I can add to
it's
that,
a way of really
in our undertaking the master planning, our key point in undertaking this level of data was so that we could facilitate decision making with our clients around that data that they hadn't ordinarily been able to look at. So we might be able to relate to our clients that renovation of one building might save them $20,000 a year in energy based on our indications or understandings of the mechanical systems in there, the cost of running those mechanical systems. versus another building that might be able to save $50,000 a year by its renovation or new construction. And our point to our clients was our facility planning, our master plans, will allow them to prioritize projects not only on the square footage need or the perceived need of the condition of the rooms, but also on energy costs. Because it was from our point of view, as we looked at the California community college system, and likely much across the states too, is that there isn't a whole lot of facilities money available at this time. And if that money was going to become available, it was going to have to come out of their general fund. And that was only going to happen if they could realize costs. So what are the returns on investment that are going to come out of the things that may be projected in our facilities planning? That's a lot of what's also coming out of this. As we talk about these buildings that we're playing with today, some of these decisions about the costs of those buildings coming online, the ability to maintain those buildings is just as key.
Right, that's great. Thanks, Rob, there's a lot more to this, obviously. We're trying to hit some main concepts, and again, we're going to be loading a lot of stuff to you, but we want to show how teams can focus on different parts, and Rob's team was focusing on the master planning, but they also got into the building itself. They were creating COBie output. Every one of those buildings now, because they're collecting data with iPads and feeding it into a database, is creating a COBie output automatically on the fly on the backside, which you'll see later on as well, too. Another theme is focused on this clinic. This is a clinic. Imagine this is a program requirements. Here's all the spaces we need for a clinic. These are color-coded by something called SEPS, Space Equipment Planning System that the Veterans Affairs and the DoD Medical Health System uses. We weren't planning on this, but we just, as we were heading into this BIM storm, we got awarded a new task from the Building Smart, from the National Institute of Building Sciences, to help VA and DoD to canvass the industry to find best practices of what solutions are there for planning facilities, going into CMMS, working with other owners and hospital healthcare groups, and finding out how they can transition what they're doing right now in a very static format, even though it's kind of they're heading towards the web. It's still not dynamic like what we're showing here. They want to get into this dynamic web-based web services format to see what opportunities there are. How do we connect to others in the industry? How do we connect to builders and designers and other software vendors? So this is color-coded by SEPS data based on the VA standards. So imagine this is a program requirement model, and the lines are adjacencies that say this room needs to be near this other one here. That's what these rubber band lines are. And Trelligence, who's also part of this BIM storm, that has a similar thing in their tool. So a lot of the dream team that's involved here, you'll notice that some people think of us as competitors, but it's really not the case. It doesn't work to be competitors and say we're going to do things our way and we're not going to talk to anybody else. We have to be able to connect, to be able to move this data back and forth between different teams. And this building, I'm not going to drill all the way down into the room level, but it has about, I think, 6,000 or 7,000 pieces of equipment in it with attributes associated with this equipment in this lightweight model. But it also has the equivalent Revit model and equivalent Navisworks model with the same data. When we open up the Navisworks model, it actually hits this data from here to pull it in. So that was the exercise that we went through to say what happens if we define the requirement for a new clinic on this campus site as part of the BIM storm and open it up to the teams and see what they can do with it. And that's what's been going on over the last few days and even until a few minutes ago. In fact, I'm still getting emails here from the teams that are working on it. So it's happening live, and that's the intent of the Friday session, is to show you what the result of this is. So Rob earlier we had it on the east side of the campus, and he said the owner wants it closer to the west side because as a clinic it's better to be near this public road on the west side. So we're going to take this parking lot out and have to find a new spot for it. And the GIS team from the Foundation of California Community Colleges, with their GIS data, this just came in just a few days ago. There's the floodplain line. That's floodplain, and that's earthquake fault right there, coming from another server. These are multiple servers saying, here's where your fault lines are, here's where your floodplain is. So you're able to get this dashboard view as an owner or as a designer of what's going on, what decisions are being made, because we call these train wrecks, actually. We love train wrecks. We love virtual train wrecks, because if you want to create the train wreck before you put it into a floodplain and all of a sudden decide you have to redesign the building 2 months later, or worse happens, right? So the ability to visualize things in these BIM storms very rapidly, like a workshop, is one of the outcomes of this. All right, so I'm going to switch gears a little bit here. We're actually on schedule, surprisingly. I'm having the schedule kind of show up here. This is one BIM storm around this campus. At the very same time, just the last few weeks and even yesterday, we had a webinar with Oklahoma, the City of Oklahoma City and the University of Oklahoma School of Architecture, and they're working on a BIM storm for the design of the city. And Fineth, are you online?
Yeah, I'm here. Hi,
Okay, I'm going to open up the studio here. Why don't you explain a little bit? We're jumping around a lot, but I want to show. I'm kind of getting to Oklahoma. So I'm going through my server and basically hitting the projects that I'm interested in. I'm logged into these projects so I can see what's going on here. And Fineth's going to describe what's going on here in Oklahoma City.
Well, in Oklahoma City, we've got a situation where the city's planning department has bought in and is one of the main players in the BIM storm, but it's really built around the University of Oklahoma. Two studios, one in construction sciences led by Tammy McEwen, and one in architecture led by Lee Fithian. Their students are really the principal players in this, and what they're doing, they've gone out and they've tapped the local firms that these students are either working for or going to be working for. The firms are coming in and they're putting firm members, pairing firm members up with student teams, and they're doing analysis and development as these student professional teams. There are other teams that are coming in and just doing the normal BIM storm things, but the student teams the construction sciences students are focusing on things like clash detection. They're going off into Navisworks and doing all of those kind of high-level clash detection. They're doing detailed cost estimating of their of the schemes that they're working on. Professor Fithian's class is working on developing concepts largely in Revit that are going back and forth. We're actually working with them right now. They're looking at going back and forth into the system to be able to start really getting into a rich data managed situation with their design process. As always, it's a bit hard in the academic environment. You've got a curriculum to work with that says you must teach these things at these times during the process, and so the two professors are wrestling with how to mash data into what we all know as a profession that really kind of values graphics above data in most cases. But they're producing a lot. We're starting to get a lot of options, a lot of schemes. As Kimon is bouncing around here, you're looking at what's called the Coeur d'Alene district in Oklahoma City, where they've actually I went to the University of Oklahoma for my master's degree, and at the time, that blue that you see on the screen right now, which is the Oklahoma River, was a ditch. And so they've actually come in, they got the Corps of Engineers to come in, they've dammed the river, created this large river where they actually have an Olympic rowing venue on it. One of the National Olympic Training Centers is there now, and this new river they've created. They've created canals and all that kind of thing to kind of do the same type of thing you see in San Antonio. And what's ending up happening is they've also realigned an interstate going through downtown, so they've moved the interstate away from downtown. And so they've basically created urban areas that are now, because of these infrastructure changes, become really prime development properties, and that's kind of what we're working with. And Kimon's showing, I guess, some of the one of the things we've done in this BIM storm is, since we really don't, as in most of the BIM storms, we don't really know the skill level and the training level of a lot of the participants. So what he's showing right now is he's showing prototypes that have come from other BIM storms that are made available to the people who are participating, so they have a test platform to work with. And I think that's what you're showing there, if I'm correct, Kimon. Is that
right?
Correct.
And this is going on live. In fact, next week you're going to be there in Oklahoma City, and I will be too toward the end of the week, going through this as a live exercise. So this is another BIM storm. These two BIM storms, actually, they're Orlando, and this Oklahoma City one's been going on for several months. The students and the professionals are involved. And the fact that, again, we're getting GIS data from the city, so we don't have to go and get a CAD file and bring it in as a background. We have the parcels and the buildings and the waterways and the parks, etc. And then being able to layer these buildings that you just saw in 3D on top of that, on top of their actual data, and run reports. It's really heavy on the eye of BIM, the information of BIM. And then these geometries can then be passed on to design teams that can continue with the design into more detail. Okay,
right.
next.
Come on, it's just one other thing, and what we're seeing this is a really good example of how we're hoping to really show how a city planning department can take advantage of all this data that they have to mash everything up together and do the same kinds of things that California community colleges are doing.
Yeah. So one output of this might be if you're the city planner or an owner and saying, well, how many units of housing do I have on this lot? It could be something that comes up on an iPhone if you wanted to do that. The same method I was showing with the work order, you reverse that and say, now I'm publishing out as I'm moving buildings here, how's my project looking on my iPad, and compare my schemes and what year are they getting built. All that kind of data that's not fun to manually do, all of a sudden starts crunching and giving you a graphical input. A completely different view of BIM, but this is all BIM because it goes into the detailed design and construction if you want. All right, so next we're going to go over, we went through this. These are actually some other community college camp. These are going on right now as well too. Teams going out and collecting more data, just like Rob was talking about earlier. Next, I'd like to go a little bit into the design, using RIM data sheets, going into design and heading towards design and construction. This is a group called D. Rofus from Norway. Rolf actually is in Manhattan for the next 6 months from D. Rofus, but he couldn't participate even. I was on the phone with him in email this morning. He didn't even have internet access. So he pushed the work over to Norway because Manhattan's down. So this morning he pushed it over to Norway so they could pull the data of the COBie, of the clinic file, into their tool through the model server that I talked about earlier. So take this data, RIM data sheets from COBie, import them into D. Rofus, create RIM data sheets, then start doing analysis with that, start adding and connect it to Revit as well too. This happened just within this morning actually. And then show that graphically, color code spaces that are out of range, for example, based on the program requirements from the VA SEPS data, do this design that's evolving, upload that back to model server. I'm not going to get into the technical aspects of this, but a model server is a place where you can park building data that can then be accessed by other tools, so COBie and IFC. Some of you might know about that. And validate the report. So tie that model graphics to data that outputs and inputs with that to be able to analyze that. There's another, so there's a COBie file from that, Building Program Information Exchange. A lot of technical stuff happening in the background, but the point is that we're moving data of that clinic model. All of a sudden now it's in a different tool that's heading toward design, and they're validating and creating RIM data sheets with that can then be passed off into the life cycle on operations and maintenance as the project gets completed. So that's actually pretty interesting. So D. Rofus, there's another group called Trelligence that is not online today, but we might have some input from them by Friday. And then the Onuma system, which I showed you earlier, essentially they do similar things, but they're also very complementary. They do different levels of detail as far as the type of data they access. And we've all participated together in BIM storms for the last few years. This actually is from Fineth Group. I didn't introduce Fineth. Fineth is the author of Big BIM, Little BIM, who spoke earlier about Oklahoma, and he has a group called Design Atlantic, and his son is an architect too. I just got this just a few hours ago. He grabbed the clinic model, pulled it into, I think he was using Grasshopper, and then I don't know what tools he was using, but essentially he took the model data, pulled it into his tool, a certain tool, and started doing different designs with that. And he's still working on that right now. I think I was getting a few more emails. Okay, so let's take a breath here. I hit you with a lot of stuff. I wanted to, are there any burning questions that I'm missing something or somebody really wants to ask right now? Otherwise, we'll keep on rolling. Yes?
English, Spanish, and things like that. How does all this work with those kinds of tools that everybody already has in place?
Right, great question. So I'll repeat it for the audience online. A lot of us already have tools that we use like Arquibus, Maximo, other CMS systems, other BIM applications. How does this fit with what I just presented? It's even with I didn't show the details of the California community colleges, but all of these tools, as they start opening up and connecting to each other. So for example, let's say the Arquibus is the authoritative source of data that you have about facilities and you want to move it into some of these other tools. As long as data can move in and out of each application, then you can start doing other things. And I'm not suggesting the tools that I'm showing you here should be the final resting spot. The point I'm trying to make is that all these tools, just like the internet, should be plug-and-play modules that can be easily replaced if your need changes or if another more competitive tool comes along. In the past, a lot of these tools that were very powerful but very heavy but very difficult to move away from and very difficult to move data in and out of, as owners, and we represent a lot of owners as well, we actually create strategies for this. Strategy is really to ask the question of the software tools that you use, just like a bank. I'm bringing money to the bank, I want to get money out of the bank when I'm done with it. Can I get my data out of your tool into any tool that I want? Because it's not really about your tool, it's about my data and the way that I want to use it for the life cycle. Otherwise, you get trapped into one tool. I'm not suggesting what you talked about is being trapped. I'm just saying that if you think of it in those ways, then you can use all the tools together. You can use the tools that you wish to work with, and especially in a world like this where you can't really solve everything with one tool, you have to be able to move things in and out, just exactly like the internet works. That's why the internet has exploded, because we don't have to say, well, we saved a Word document in Internet Explorer version 1997, therefore we can't open it today. HTML kind of more or less passed through, and you're not having this versioning problem. The California community colleges, and there's presentations on the web about this, they've declared that they want to work with vendors and solutions that have open standards, web services connections, and be able to pull data, not to export it to the tool, but pull it and use it in this way, and then plug it back in to do other things with it. Because if you have a two-way connection, all of a sudden a tool that does really great things over here, that data might be very valuable in another application that doesn't even exist today. Things are just coming online all the time. So that's really the opportunity. As owners, you really have that ability to kind of declare, well, this is what we want to do, and then the industry will move your way. And I think that's the tipping point that's starting to happen, I think. And a lot of these tools really have to work together to be able to do that. And in fact, this slide is kind of an interesting one relating to that. So if you think of a map like this, you have Hong Kong on the left, and you say, here's Hong Kong, and you have a city model there, and you have a building model in the city. You go into the building, you go inside a room on the certain floor, and then you have a carpet, and then John is sitting in that room. This makes very much sense from a linear perspective. You point to things, but from an extreme angle, you can also look at it like this. You could say, well, I don't care anything about the map. I'm just in this room, and I want to get a bid on carpet in this room, and I want it delivered to Hong Kong, and I want it to have certain characteristics, and I want it to know that it's part of this building. Very simple concept. In the opposite direction, you might say, I don't care anything about the detailed BIM. I just want to get an alert on my phone that says there's something happening with the pump in this building 101 in Hong Kong on the 3rd floor that's affecting these occupants because we're getting a lot of work orders in. So if you strip away this, which tool do we use along the way, then you're able to pull it up with the application that you want. All right, let's do kind of a spot check here on time. Amber, who's ready to go? I know that Jason was waiting to go online till 4, right? He's probably not on ready yet, right? So we'll keep going a few more slides. We're going to have Balfour Beatty on here in a few minutes. We're actually a little bit ahead of schedule, so we can take some questions as we go along here. The other end of the spectrum, and we'll show this live in a second here too. This is part of the BIM storm. We actually inserted this building in here. Once you have all this stuff in place, everybody looks at all this amount of data and says, wow, how am I going to keep up with maintaining and managing and putting data into this? It should be populating itself. So if work orders are coming in from people inside the building, all of a sudden you can turn the building plan red and say, well, there's a lot of work orders coming in here. Well, something's going on with that system. Well, what's that system? These buildings with building automation systems and sensors are starting to talk to us now, right? So they're broadcasting out and saying, this is a temperature I have in this room. That data is, again, web services. There's a group called Opto22 and another one called Energol that we connected to these BIMs from the California Community College. So now we can see sensor data, live sensor data that says here's the temperature in the room, or here's the condition of the room, or even let's go and look at what's going on with the lights in the room and turn the lights on and off. And I'll show this in a few minutes if I have some time. But you can literally go into the BIM, open up the plan just like I looked before, and if there's a sensor and a light switch, you can actually turn the light switch on and off. The point isn't that we can turn lights on and off. The point is that as these systems start getting more intelligent, you're able to do things like this, to connect to data and to be able to control the buildings or have them talk to each other and say there's something going on here, so you don't have to have somebody manually go out and manage the facility in ways that were not very efficient before. So the technology is rapidly changing. The culture is going to take a while to shift, but these little tidbits, and we want to, in BIMstorm, we want to broadcast out. This is actually happening. We're not making this stuff up. There's actually things like this already happening on projects that can completely change how you look at facilities, how you manage facilities, how you go into operations and maintenance of facilities. In fact, since we're here, let's go ahead and just show real quickly. I think it's in this room here. Okay, so we go into this room. Amber, tell me when, let me know when Jason's online, and I'll switch over as I finish this. We have Jason from Balfour Beatty. I think they're coming on at 4, correct?
Yeah, we have him online and Jesse and Kurt.
Okay, so give me a couple minutes and then we'll switch over.
Okay.
Okay, so this particular room, this is a very simple floor plan. Again, remember that we have the equivalent Revit model with full-blown detail that you'll see later on as well, but we also want to have a simple view of the same data. We don't want to have equipment data in one model, equipment data in a detailed model, and they're not in sync. You have to be able to broadcast out. And these models, what's happening, the data should not reside in the we had a discussion this morning. Should the data about a piece of equipment and the SKU number be in the object inside the BIM that's used for design and construction? Yes, it can, but does it make sense to be there? If you want to maintain it, it actually makes sense to split off a lot of the data outside of the geometry and use the geometry as a place to connect things. And that's exactly what we're doing here. This model originated from Revit, but we added this camera to it. This is actually a live camera from one of the community colleges. It's asking me for a password. And here's the live shot of that room. The lights are on. And I want to go and see what's going on with those lights. This is a mashup. These are different pieces of software that are being pulled up. That little blue box is coming from a group called Integral. It's just a web services call to their interface that they create and maintain that's connected to this light that says here's how much energy this light is using. And if I want to shut the light down and I have the right password, I can go in and turn this on and off. So there's a light on and off. This used to be very complex and very expensive to do. Now with these sensors and the technology, the price is coming way down. And like I said, the intent is not to go through and turn on thousands of lights on and off. But if you have demand response events and say we need to shut this building down, okay, we need to shut it down. Are there classes being scheduled right there right now? How many people are in there? Can we reschedule the rooms to another building that has the same capacity of laboratory space? So as an owner, you need to have this kind of a view of your information that by default is being collected and created by the building industry, architects, engineers, and builders, that if you tell them how you want it delivered back to you, like the California Community Colleges, all of a sudden you have this rich set of data that you can start doing things like this that you don't have to pay to get again. Because I know, I've seen this over and over again. Buildings are completed, owners take delivery, they hire a whole other team to come through and scrub through the building to find out what's in the building, and then they do it again every few years because the data starts to what we call rot. It starts to get stale. So if you keep it live like this and you keep it lightweight, then you're able to keep it in a format that's you're able to start using this. So one other point before we switch to Jason, this thing about the light and what temperature should this room be? What temperature should this operating room be? Well, that originally came from the owner that specified the requirements from that room, that was Veterans Affairs or DoD Medical Health Systems. We want to be able to track that information, that thought in the program requirements all the way through design and construction and commissioning and delivery and then operations to say this operating room is functioning based on what the original assumption was, and did the original assumption change? Because that happens as well. So all of this is dynamically changing. Buildings are constantly changing. They're constantly renovating and moving and changing use. So this live access to information changes how we can manage that. Okay, Jason, are you ready to go on?
Hello, come on, can you hear me?
I can hear you. We can switch to, Amber, you want to give the screen to, why don't you introduce yourself? I haven't introduced, I just said you're Balfour Beatty. That's all I said so far. So you can introduce yourself and your team. One thing I can say about Balfour Beatty is that they've been very involved with BIM storms for many years. They've brought in other architects and engineers and builders and other parts of the industry into the BIM storms, and they've used this to apply it to their projects and their tools and processes they use. So it's kind of a learning process and bringing teams together. So Jason, thanks for joining us today.
Yeah, no problem. I'm Jason Reese. I work for Balfour Beatty Construction. I exist in Fairfax, but I tend to be more of a virtual entity throughout our organization. And part of what we do out of our group here that we call Technology and Process Development is constantly look for ways to improve various processes. So we've participated in BIM storms for, I guess, 3 or 4 years
Jason,
now. Yeah.
Jason, we don't see your screen. Are you sharing something?
Oh, I'm not sharing anything yet. Is it a blank screen?
There's a blank screen.
Can you see something now?
Yeah.
There we go. All right. Well, I'm not really sharing anything. I'm just.
Okay.
Anyway, so we've participated in several years because we find that the BIM storm is enabling us to more rapidly produce information to help us make better decisions. So we're taking the concepts behind BIM storm and planning. We're constantly evolving a way of doing what we're now talking about as rapid prototyping. So what we've done in the past is so what we end up calling a traditional BIM storm is we take the Enuma system and we'll start developing schemes. We'll make models of those schemes. We'll involve expertise from within our company about planning. This is a rows demo, what we need to do in order to revive the site, create massing schemes, and from those very early models that you can see right here, there's almost no information, there's almost no model content there, but there is a lot of information there, and this information is pulled directly out of the Enuma system, and we can very quickly look at different iterations of the design to be able to say how much is this going to cost for across these buildings, what kind of decisions are we making with these massing models, and then we can also look at life cycle cost, total building cost. We can take at that very early level and do schematic design, doing very schematic level estimating to be able to take our historical cost database and be able to figure out what is the first cost relative to the design at the time, and then we enable partners. This is Walter P. Moore, who was on part of our team, not part of our company, but part of our team, and to be able to apply structure, and we'd be able to get takeoff out of that. We had several of our sister companies involved putting the skin around this various projects, and then we have a campus and structure, and we can do takeoffs on that to get more refined information, and then we can started going through energy modeling, extracting information out of the Enuma system, and then constantly looking at, all right, this is how much energy we were using. If we make different decisions, what happens? What happens is the energy starts being reduced, and then make more decisions around making different tweaks to different areas of the building and constantly looking at how do we reduce things. And it comes down to, if we do this constant prototyping approach that the BIM storm concept enables, then we're able to make better decisions with information rather than spending a lot of time developing one scenario and then analyzing it to see if it met the criteria. So we're using information to make decisions rather than checking to see if we made all the right decisions to meet the goals of the project. So you can see just various analysis of different things here. But as we got started developing our methodology for last year's BIM storm, we started involving software, different software vendors. Like this is a shot of Vico, where they evaluated 3 different schemes for the Miracosta campus, which was part of last year's BIM storm at EcoBuild. And we were able to get schedule and cost information for comparing different schemes against each other to figure out this this building, this version is going to cost $25 million and be 60 weeks, and has some inherent cost and schedule benefits over another scheme which we also developed, and that's information to help us make decisions. But we can also use tools like that along with database information to figure out what life cycle costs are going to look like in comparative analysis between different structural systems and first costs of the building. Then we started looking at taking those same schemes into programs like Vasari, and so we have 3 different schemes here, and we run an energy analysis on it. And what are we able to do across those? We're able to take 3 different schemes, run a couple different energy analysis, and we start building what looks like this, which is a traditional process. You make one decision that puts you way up here, and then you choose between 3 other options that might put you up here. Traditionally, the way we don't have enough information to know what all these costs are, and often we don't carry forward what we call sets. These are 3 different options early on. If we were to carry forward those further and look at them against other decisions that need to be made in the future, we can start seeing that the decisions we want to make are in this lower area here in order to reduce cost, and it means one of these 2 decisions is the appropriate one rather than making this one. So how do we get more information in order to get there? And that's what we started seeing with Beck Technology. I give them a lot of credit for pushing this concept forward, where they started automating the process of getting many different iterations of a design against energy, against cost, and they called it their optimization process, and it fits into this prototyping concept that we're trying to achieve. So what we're doing now for this BIM storm is a progression of that, where how can we start really putting methodology behind this rapid prototyping concept. So with that, just real quickly, we're going to be we're developing 3 schemes. We're doing rapid analysis that we're going to show you, and then we're going to be putting reports that consolidates the data and it lets us make better decisions potentially on a project. So I do want to turn it over to Jesse right now so he can show what we've done so far in Enuma and transferring things over to into Vasari, and then we'll show you some of our early work on doing the rapid energy modeling. Let me turn that over to Jesse quick.
Do you want to make him presenter?
Yes, please.
Oh, okay.
Just so everybody knows, Jesse also works for Balfour Beatty as one of our frequent BIM storm supporters and doers. So he's our resident Enuma expert. So whenever I need some help, I go to him.
All right. Well, thank you, Jason. Can you hear me well and see my screen?
Yes.
Okay. So I just want to talk for a couple minutes here. And Jason described this this constant prototyping, design optimization sort of scenario. And I just want to take you through a couple of the very earliest steps of that process that we've gone through so far this week. And the steps that I show you, I mean, these are everyday, very standard parts of the conceptual / schematic design process. But what I want to look at in particular is in this BIM storm environment, what does that data look like as it moves through these design phases? How does the information flow? So what we're looking at right here, this is a scheme from Enuma. This is Kimon introduced this earlier. This is the clinic building that was dropped onto the Fairfield site for any of the BIM storm teams to pick up and sort of do whatever they want with. And we decided we wanted to make this an exercise in design optimization. But there's a lot going on in this building. So the first thing we did is just simplified this building and took it back to closer to what I guess we could call a really early, really conceptual program. So the first thing we did is we looked at all the spaces. We exported all of the spaces from this scheme into Excel, and that's one of the great information transfers, but in and out of Enuma is Excel, because Excel is so universal and so easy to use. And we just whittled it down to maybe a couple of dozen major departments inside this building, and pushed that back into Enuma. So and this is one of the really cool, really important steps in any design, is when you move these spaces from ideas or line items on a spreadsheet, when you push them over and turn them into tangible geometry that you start moving and shifting around and setting in place in your building. So we got it to this point and then engaged a few designers from Parsons Brinckerhoff and gave them access to this scheme where they took these spaces and just arranged them and they started doing this yesterday morning, and by the end of yesterday we had two developed schemes inside of Enuma where they took these spaces and just arranged them and created buildings. There's 3D masses associated with these spaces. They inherited the actual location of the site from the original Enuma scheme, and we took these models. Here's a look at taking one of them right from Enuma into Revit as a massing model, right? And then we took this massing model, moved it right from Revit into Vasari, which is an energy analysis program, and started doing some of these iterative evaluations that Jason described for the design optimization. And so I guess the theme that I want to, from all that I've talked about, that is kind of the coolest thing or the most important thing, is how well this information transfers from Excel to Enuma to Revit to Vasari. It's all about capturing that data and making it useful over this entire life cycle. And Jason, were you going to now look at a little bit of what goes on inside of Vasari?
Yeah, I'll go over it real quick how
Excellent.
we're pulling data through this transfer of model information between different software. So you can give me control back.
I'm seeing this for the first time too.
So this is the original scheme that we pulled over from Enuma that had all the spaces in it. We didn't need the departments or anything, so we stripped all that out just down to slabs and created this massing model. So basically, we started with this concept and say, all right, this is our starting point. So how do we run an analysis on this? Well, in Vasari, we can go into here and we can start looking at conceptual design. So we can look very quickly at, we have a mass exterior wall. Well, what do we want? Do we want to choose between lightweight construction, might be metal panels, it could be a type of ephes or something like that, or it could be a lightweight construction that has a very high insulation factor or low insulation factor, or it could be precast or brick. And these are sets of major high-level sets of information that we want to be evaluating. What is the right choice of cost versus energy, long-term energy performance of this facility? And we don't want to just evaluate the energy after we make all these decisions. So this is where a tool like Vasari is really helpful. So you can look at all these sets here, glazing, various things like that. We can change the glazing percentage really quickly. I can change this to 60% in here, and you'll probably notice that the windows got bigger right there. I've got sunshades on these windows and that type of thing. But then I can go in here and I can analyze the model, and I hope I don't regret hitting that button. Every once in a while it'll crash out on me. But what I've got here available to do that, you can see that energy analysis that I said to create is actually cranking away right here, and very quickly too, because it's a very light model, very small amount of information. Now we're looking at different options, so you can see here we have different options we've created. I can do a quick comparison of these. So if I look down here, I can see the life cycle energy cost of the scheme is 1.2 million, a little bit less than 1.2 million, and then somewhere in the middle between the two. And all I've really done between these three schemes is really vary one aspect of it, which I think was the wall construction between one system to another system to another system, and it now returns energy information that's different for each scheme. It returns life cycle information. It'll tell me my carbon footprint consumption and then potential ways to offset that through photovoltaics. But that's only a very small amount of information. What we're trying to achieve is rapid energy model and make a lot of different decisions. This might be hard for you all to read. I apologize. I'll try and zoom in a little bit here for you. So this is where we're using Excel to extract the data from those reports. So very quickly, I'll scroll over here. So these are all our sets of information. So we're looking at the roof, sunshade, glass percentage, glass type, and exterior wall. And we're saying for one set of information, we're going to look at high insulation with sunshade, with glass, so 40% glass, with double glazed tinted windows, and with high mass facade with mild insulation. And then we're going to run another one and only change one aspect of that, one variable, which is the move to high insulation rather than mild insulation. And you do that enough times, and with the sets that we proposed here, which is only 2 options for, if you can think about how many options you have for glass and roofing material and exterior walls, this is really only one or the other. We have 32 different options, scenarios that we're going to run. And then this data right here in the energy data column is extracted directly from those Vasari reports that I just showed you. So we have our different schemes that we have here, and then what we're going to do is Veeco is supporting us in doing cost analysis of all of these sets. So they're going to run parallel to us doing the energy, these sets in their system and extract the quantities. And these are some dummy figures I put up here just to test my spreadsheet. But you can see here that if we hold the non-set part of the building constant, which I just put a number in there, that seemed to work for a clinic, you can see varying costs, and I can see my high cost for the building of all these sets are 5.7 million versus 5.1 million, or an initial cost difference to the project of about 10% of the project. So the question is, do we want to go low cost on this job and save 10%, or do we want to be somewhere in or at the high end or somewhere in the middle where we're balancing energy performance versus initial cost? And that's where the energy performance. So we can plot initial cost of each option versus energy performance and see where we want to fall and make design decisions based around these different schemes. And this is just for one scheme. We're going to do this for 3 different schemes. This is the original one. We have 2 other schemes that we're working with. So we'll have a total of 32 times 3, about 96 different schemes that we've analyzed, and we're going to be able to aggregate them into some reports that help us make decisions about what we want to do with our facility. So anyway, that's what we're working on. Nutshell, we'll continue working on it today and tomorrow, and then hopefully have a good report back with some, hopefully some good information on Friday.
Great. Thanks a lot, Jason and the Balfour Beatty team, and Jesse. We'll hear back from you on Friday. Okay, Beck Technologies. Mark, are you ready with Deep Profiler?
Yes, I am.
Okay.
Can you hear me?
Yeah. Are you going to show something on screen, or are you just going to talk?
Yeah, I have the live model available.
Okay. First time I'm seeing this as well too. This is all just happening in the last few hours today, I think, right?
Yeah. Yes.
Okay. Oh.
Well,
okay.
So my name is Mark Godfrey. I'm with Beck Technology, and what I'm going to be showing you here in the next 5 minutes is going to be the model that Kimon has sent to us, and that we have pulled into Deep Profiler and have attached costs to it, and now we're going to be ready to hand that back over or have it be absorbed by another software package. So the file that you're looking at here is what we pulled in the last, I would say, 4 or 5 hours. We pulled this in and costed it. And what you're looking at individually here are the rooms that were pulled in. And then we went in and applied a building type to this, to these rooms. And we're able to come up with cost for each one based on the square footage. I'm not sure how much everybody is familiar with Deep Profiler, but basically it's a parametric macro cost estimating software, which allows us to change the size of a room, and it automatically changes the cost as well. So you'll see just a quick explanation and example here. You see the room that's pulled out. I just did that. That's the one on the bottom here. So we know we're looking at 834 square feet, and I'm just going to hit undo, and it's going to go back to what it was. And after it thinks for a little bit, that square footage will go down, and in turn the cost will go down as well. We won't wait for it. We'll just move on. In addition to the rooms, oh, there it goes. So you can see that cost went down. So that's just a small example of what we can do on an entire building basis We can do that with room interior finishes. We can do that with structural cost. And in the massing, we can do it with all our MEP cost as well as our cladding. For instance, right now we have a blended cladding on the building. We have 70% brick with metal stud and 30% punched openings. And that takes the entire square footage of the exterior building, and it applies cost that we have associated with the brick and then the cost we have associated with the punched openings to those percentages, and we come up with our total cladding cost. As we go into the structure and take a look at it, just for the purposes of today, we applied a standard concrete frame to this, so we're looking at a slab on grade. This is our first level. As we go up, the program automatically knows that we're going to level 2 and then level 3 and then level 4. It knows that it would be the roof, so that we have roof insulation and roof blocking, that sort of thing as we go up. The last portion of it in this particular model would be the MEP cost, and those are all assessed per the square footage in a similar way, but in a much larger fashion as the room work. So once we have all of our costs associated and we've gone through and we've checked to make sure that everything is correct as far as the unique portions of the building, anything that, because what we've done is we've applied a database, so what we have to do is go back through and check to make sure that there's any uniquenesses about the building. For instance, the interior finish cost per square foot, is it correct according to any information that we've received about the building that would change it from what we had in the database. Once we do that, we go in and we print off a report, which I have one here I'll pull up. So at a very early stage, as Kamon hands us the model, whether that has gone through design or whether we're actually pushing and pulling inside of Deprofiler, we can go in and get a very detailed cost at a very early stage. For instance, right now we're looking at the exterior brick. So we can say how much brick we have, how much it is per square foot, and this is our cost. If we want to go in and change it to maybe 80% brick, we can go in and do that and quickly see how that's going to impact the cost. If we receive last-minute news that brick has gone up or brick has gone down per square foot, we can change that and get that updated in the model fairly quickly. And in addition to cost, what we can also do with Deprofiler before we send it back to another type of software, obviously we can go in and we can change the blocking, the stacking. We can also put together a sequence for phasing, which we do quite a lot in our planning programs that we do, where we'll go in and the campus wants to finish out one building first before we finish out another, or maybe there's one floor that needs to be finished out first before another. We can go in and assess the cost of doing each one of those individually, and then go in and assess that to a sequence, a broad general sequence. We also work with the optimization of the plans as well. And from this point, we can go back into ops and hand it back over the fence, or we can have it absorbed by another type of software. So that, in a nutshell, is kind of what we'll be working on.
Great. Well, thanks for jumping into this. It's nice to see. And it's we're working with Beck and Deprofiler on some government projects right now, and you're getting a glimpse of what's going on there with these workflows. Okay, Igor, are you ready? Can you do it in 5 minutes? We'll wrap up again on Friday, but if you can show us.
Sure, I'm here.
Okay.
Can you hear me?
Welcome, yeah. You were supposed to be here in Orlando, but you didn't make it down.
Yeah, they canceled my flight, so I'm sorry about that.
So
because BWI was closed yesterday, so.
Right.
Anyway, do you want to, do I need to show the PowerPoint or just jump into the software?
Why don't you jump into the software? We could show the wrap up with PowerPoint.
Yeah, the idea was is that we take the standard COBie file, as you can see, produced by Anuma System, which is pretty much the same file that Building Smart Alliance was publishing for all of us: floor, spaces, zones, types, components, systems. So what we did is pretty much, while I was listening to you, I went into Ecodomus, created an empty project called Beamstorm, and imported that file, this medical dental clinic COBie XLS file, right? So here, obviously, we parsed all of the entities and we placed them into the appropriate places within Ecodomus PM software. What you're looking at is the Ecodomus PM. We also have Ecodomus FM software for the facility owners. This is where the data is being collected, verified, because we have various reports on checking what the attributes are missing, the quality control stuff, etc. But the idea pretty much is to allow those who don't really deal with 3D or BIM be able to still edit all of the information. So for example, I'm looking at the type name AHU, so that's our type. Each type obviously has components, so this is the AHU1 and AHU2. I can look up at this AHU1 component. I can see the data that we imported for it. I can look up at the location for that AHU, so this is the space that was imported. I can look at the room data sheet, what are the other items that are assigned to that room, go to the boiler from here. So you see, you're jumping from one entity to another entity. You can always see other elements of it. So for example, here's my boiler. Boiler is obviously on the HVAC heating water side, so I'm jumping to this system. What other elements are in this system? Oh, air separator and expansion tanks, etc. So we can navigate through all of those elements, just going through this as pretty much the same as you see in the Excel file type, component spaces, document systems. You can see it all in here as well. If you want to deal with the 3D, then you go into the kind of a 3D view of that. The same COBie Clinic file that we had the information from was published as the Revit. Anyone can see that and download it, a public file. So we created a Navisworks file for it and published it here in our server. So what you see right now is I'm loading that 3D model into my browser, and we simplify the view, even though the back end, as you can see, is the Navisworks model that is being loaded. Pretty sizable model, but anyway, here it is, right? It's loaded into my browser, so here it is. This is my model. But it's a pretty much empty model, right? So most of the elements of this facility are not available right now, so because it was not populated. So I created a few viewpoints here, and I can now link detailed information to my graphical elements. Pretty much anyone who's dealing with existing facilities or with most of the BIM projects, because most of the BIM projects, to be honest, are producing pretty much empty 3D files, even though they call them BIM files, but those are pretty much only 3D files. That's it. There is no intelligence in them, especially that related to the systems assignment, the zones assignment. Those are very, very bad. Just modelers right now are not yet, they don't know how to model all of these complex relationships. So I can select any of the objects, and what I do next is I pretty much saying, well, I know that this is a chiller, so I want to link it to my data. So I pull in my data sets, and here's my chiller, ACC1. So I assign it to this element. So now this element is not just some dumb 3D object, but it is actually air-cooled chiller. And all of the properties that you have just seen on the previous pages in the flat web interface are now assigned in here, including the information about the documents. So yeah, the biggest challenges what we've seen is right now is not really related to the import or export. It's related to the collection of the data and explaining it to the modelers, architects and engineers and contractors how to collect that data, how to connect those systems, how to deal with Revit, how to explain them, for example, that Revit built-in OmniClass library is not usable. As you can see here, it's not available here because what happens is, even in the test file that is published on the Building Smart Alliance profile, these categories, these OmniClass categories, they are from the outdated OmniClass library that is no longer valid for at least 3 years. So there are issues in the industry that we're trying to solve. And so, again, technology is there. It's the actual training of the end users, training of the owners that have to be performed to make it all work perfectly. So you can achieve what Kimon showed earlier, you know, this energy analysis and advanced connection between multiple systems. One of the projects we're working on right now with GSA and the Camden Courthouse is actually related to connecting the information that we collect as the COBie elements, so kind of a design information. We built a Energy Plus model, simulation model for that, and we are comparing it to the BAS data, building automation systems data, to identify that, for example, your system air distribution 02 is 20% off charts for the March, and it's 10% off charts for the April. Why was there discrepancy in March? Right. So this kind of analysis is what we are capable to do, but in order to get there, we need to learn how to properly collect the information, and we need to verify that this information is appropriate, and that's where all of this reporting is being done, is to make sure that all that works. So I know that you are running out of time, so thank you. If you have any questions, you know how to find me.
Thanks, Igor, and we'll hear from you again, or we'll review your slides again on Friday as far as the result. So it's the same data again going into multiple tools, and Matt from Broadus & Associates is going to say a few words. Broadus & Associates works a lot with COBie, and why don't you explain what you guys do, and then talk about what you saw.
Sure. Well, as was mentioned, there's a lot of teams working in BIMstorm. There's a lot of data that's being produced, and what we're doing is jumping in and not really authoring any data, not producing any, but saying, okay, surveying it, what do I have? How can I get this to operations? What good is this for me in shifting from the project, construction, design into operations? So we're going to survey what's there, what the different teams are producing inside this BIMstorm, look at the Revit models, design models, energy analysis, the COBie data, the equipment data that's there, documents, reportings that gets produced, and we're going to analyze it for operations. So first we survey it, then analyze it. Okay, how can I use this? Is it mobile enough to go to a tablet or a smartphone? How is it going to be shifted inside of my CMMS? How can I connect it to other tools? So we're going to analyze the data that's produced in this BIMstorm. And then also we're going to demonstrate the use of it actually in some operational tools. We're going to simulate the use of the model in how's it going to help me with work order planning, etc. And then also look at the COBie getting pushed to a CMMS. AssetWorks is letting us borrow AIM for a couple of days to simulate that, and then show the connection of the BIM data that was produced in all of this processes and moving it to operations.
Okay.
And then lastly, connect some lessons learned, just to make it short and sweet.
Great, thanks a lot for looking. And so Matt's been, and even the last hour again, he's been taking the COBie data. We've been actually emailing each other, and he's been pulling the COBie data that you saw from Igor and from Numa earlier, looking at it, validating it for completeness and quality. We'll take questions now, but as we're taking questions, I want to show your work orders now are on this plan. We've had over, I don't know, about 40 work orders. Somebody said there's a huge black cloud of smoke flowing out of the building. So they're gray there. They haven't been assigned yet. In other words, we haven't gone in and said, okay, you have to go do this. It's this flow of data. That's kind of the theme of this whole BIMstorm, is how do you flow data into different tools, whatever systems you're using, and be able to talk to each other. So we have a couple minutes for a few questions if anybody has. We'll be around for the next few days. Friday's a wrap-up. We're going to be roaming the building, the Broadus booth, around the hallways, actually interacting with Balfour Beatty and others online as well, too. But we'll take any questions. Or, yep, right there.
Just to clarify, I think I understand correctly. Numa doesn't actually contain any of the information, pulling information from other sources. It lives in those other sources, but all this really is an interface software.
That's not quite true, but yes, we can hold the data as well too, but we prefer to pull it rather than import and export. So if for Fusion, for example, we could have said, give us all your 120,000 rooms, we'll import them in, and you guys go away and we'll use our tool. That could have very well happened, but we didn't go that route. It's actually better to subscribe to the data. So I'm Expedia and I want to see the Delta data. But if I wanted to create the exact same data on Numa, it's certainly possible to do that as well. There's no linear path to any of this. It's basically evaluate what you have. I have an Arquibus database or whatever, and start with that. You start with what you have, and start soon, actually. That's another theme that we've heard this morning as well, too. Don't fret about it for a year. Just what you have is a good starting point, whatever it is, and just start working with it. The interoperability, yeah, it's surprisingly not as painful if you keep it simple to begin with. Then you can keep on stacking more and more. And you saw, you didn't actually see the last interface with the Igor's tool very much, but you can get into a full-blown 3D model with the same data inside a Navisworks model, walking around and clicking on things. But the interoperability, don't burden yourself by trying to say, I want to be 100% interoperable with a full-blown level of detail, 1,000 model, or whatever it is, and then try and make it work. Start with what you have, start with the data that you have, and then start stacking it together. And just like with California, they could not have waited for 5,200 BIMs at level detail 400 or 500 to be able to start managing their facility. So you come from two angles. You have to be agile and just move around and work with what you have. All right, I think we're close to the end here. Any one last question? Yep.
The processes that you went over, are you typically brought in by owner, you show them all this stuff, or you have an architect with a vision say, hey, I saw this cool guy, he showed me this stuff, or contractor side?
It varies. Right. Repeating the question is, how are we typically brought into a project like this? And this team that we actually showed you, we're working on real projects with all the people that we've touched here and a lot more. We're brought in from many. I'm an architect, and we started with BIM by working with BIM, but then all of a sudden, what happens, this is actually a strategy question just from a perspective of a business, is as you start broadening out what you can do, the more you can touch in this 21st century, the more relevant you are, and all of a sudden the owner says, wow, you're able to touch and work with all these other tools and all these other databases. Then they bring you into a more central position. So we're very close to a lot of owners recommending to VA and military healthcare systems for DoD how to go facility management, operations, and programming. And it allows you to collaborate with other specialists like we saw today, so you're not burdened to do it all yourself, which actually lets you focus on the stuff that you want. But each of our projects varies quite a bit. In the early part of our work as architects, we started heading more towards software. And we are software developers too, but what we found very early on in the 90s, if we just hired a bunch of software developers, you can't solve it, because it's not about software development. It's about the building industry, design, construction, management, and knowing how all this stuff ties together. So that's the value. The value is in our heads as an industry, knowing how to make those connections. Then the tools just become tools. They're not disposable is the wrong word, but they are kind of disposable. You just kind of start creating these applications, and it opens up these doors for you that were not there before. Okay, one last question.
On the front end, how do you deal with the sort of the overflow of information, I would say, and an ownership entity that may not be either prepared or equipped to deal with all of the decisions that this opens up for them to be able to address early on?
Right.
You know, it always gets challenged. You know, hey, you're turning on the fire hose right at the outset of the project. I'm not prepared for all this yet.
Right.
How do you deal with
That's a good question. The question is, how do you deal with the overflow of information? You getting a fire hose of data, just like you got a fire hose of 90 minutes of presentation here. I warned you in the beginning this is going to be kind of overwhelming. But think of it in terms of your iPhone, and I want to get my flight on that plane. There's a ton of data in the background that's driving the airline industry. You don't have to be worried with that. So as the industry and the software moves forward, things should get simpler. We create apps out of everything, basically. So then it's actually better to have more data. It's like Google is a little box and you hit the whole world, but it's just feeding into Google, right? So think of it in those terms, because there are a lot of mistakes that have been made in the past, especially when the storage of data used to be very expensive. So you say, oh, we can't deal with all that data, so we're going to throw it away. So we're going to throw it, oh, we got to collect it again. Okay, we got too much data, let's throw some away. And all of a sudden, you're dealing with just managing, throwing data away, not really having a sense of what's going on. And the wrong things are getting thrown away over and over again. So owners, this is actually such a simple concept. What room number are we in is not a simple answer for most owners. Is this 101A or 101B? Is this the right building? So if you can't point to this room, how can you measure how much carpet's in this room or how much energy you're using? So start simple, go big, and then start building on incrementally with modules. That's exactly what the California Community College is doing. And they didn't invent this process. This is happening in other parts of the industry. Just the building industry is just starting to kind of get into this. So concept of cloud computing. Storage is almost free right now. Obviously, you have to pay for things, but all that stuff is becoming almost a non-issue as long as you can kind of just barrel ahead and just kind of work with it. But and you need teams to do this, obviously, too. It's not something you just kind of pull out of nowhere, but it's not as complex as it seems. When I present it here, a lot of people say, well, that's too complex or difficult, and California it's a big state, so they have a big budget. No, they don't have a big budget. They have a very small budget, and that's what drives this innovation. And I present this a lot and say, the building industry, it's a horrible time right now as far as the economy and everything, but it's the best time because it's actually forced us to become more innovative. Innovation drives, I mean, these constraints drive innovation. If gas was 5 cents a dollar, we would not be driving the kind of cars we're driving today. It would be bigger problems. So it's an opportunity for those that are in there. And to be in there, the way to be in there is to connect, and you have to share. You have to open up. A lot of this kind of seems like counterintuitive, but I don't want to share my secrets. If you don't share your secrets, you're no longer relevant in this world. It's about cooperating and opening up. The more you open up, the more you connect. You might lose a little bit, but you'll move way ahead. It's just amazing how fast you can move if you work with the right team outside of your firm and around the world, just like we saw with Norway jumping in. It doesn't matter today where you are and how you're working. All right, I think we ran over a little bit, but thank you for sticking with us for 90 minutes. And if you have any other questions, I'm around till Friday, and we'll be wrapping up again on Friday. And thanks for joining us today.
The organizer has ended the session, and this call will be disconnected. Goodbye. Goodbye.